Good evening, folks. My name is Alex Stanhope, and this is a short presentation about Kubernetes. I'm often asked these kind of questions. What is Kubernetes? Why is it important? What does it mean for my applications? What are containers, and why do we need to orchestrate them? Kubernetes is a mechanism for us to deliver better service from our applications. But in order to quantify what that means, let's start with the applications. We have applications, they run, they're hosted on servers, installed on disk, they run as processes. They typically have access to all or most of the server when they're running, but the role they play is to provide a service. And sometimes we talk about the quality of service they provide in terms of the reliability and performance. This is an example of an application running on a host. And here you can see Elasticsearch has access to much of the host. Containers give us a different way of running that same application in a much more controlled fashion. So containers are standardized, they are isolated, and they are isolated from one another and the rest of the host. That makes it easier to distribute them. It also improves the security because it allows us to control more closely what it is that the container has access to and what has access to the container. Here is an example of that same service, Elasticsearch, running in a container. The container here is provided by Docker. Docker is a container platform. It's somewhat a sort of standard for containers. It's used very, very widely. It's not in itself a hypervisor, which is a word you may have heard in connection with things like Hyper-V or VMware or VirtualBox, KVM, but it does provide a level of abstraction. The idea is that it's abstracting the things running inside the container from the environment in which they run. It allows us to more closely isolate them. Docker Hub is a library of these containers. It's a place to download a whole array of different applications. We can have multiple containers. So on a single host, we can have many containers running side by side. They're all isolated from one another. The interactions between them are managed, and so we can control the way workloads are distributed within that server. We can also control exactly which of those containers can talk to the others, and that helps us provide another layer of security, this sort of onion model of security that gives us a greater sense of control. This is a diagram that shows a single host running multiple containers. We can see we've got Kibana, Logstash, and Elasticsearch as part of the Elk stack. Now, unfortunately, things can go wrong. So we have hosts that crash sometimes. It's an unfortunate part of running any kind of hardware. And what we don't want to do is impact our service. The goal here is high quality service delivery, reliability, performance, and high availability, such that if any crash occurs, the service as a whole is unaffected. We still carry on providing that. To do that, we need multiple redundant copies. So we have multiple hosts. Here's a diagram that shows 3 hosts all running the Elasticsearch Elk stack. And you can see they're running side by side underneath or behind a load balancer. The traffic is being shared by the load balancer across the 3 hosts. Now, this isn't without its complications because there are now 3 hosts, we've got an awful lot of services running. There are, all those services will need their configuration managed. We'll need to sort out the networking in between them. We'll need to work out how we're going to distribute secrets like credentials or certificates that are used to authenticate those services. The load balancer that sits in front of them is quite a simple bit of kit notionally, in that it's looking to see whether a service is running, but it doesn't know much about the state of that service or even necessarily how performant it's running. We've got a number of fundamentally identical nodes, and those nodes aren't adaptive. So if one service needs a lot more memory, we have to allocate that memory across all of the nodes, which in turn might mean sort of create some capacity issues. So we need help in orchestrating this, and this is where Kubernetes comes in. Kubernetes is a container orchestration system. Its role is to distribute and manage those containers that we've seen as being very useful things for limiting or constructing an environment in which an application can run securely. Kubernetes will help us with the networking as well in order the communication can happen between those services. The traffic can be load balanced by Kubernetes. It helps us deliver a highly available service. It will handle ingress, so we can look at the route by which traffic comes into it, and it can handle things like HTTPS offload. You might have noticed when you plug in those URLs into your browser, they almost all begin HTTPS these days, but internally we can run our containers with HTTP, and then allow Kubernetes to wrap all of that in a secure blanket. Also, crucially, they handle secret management. So Kubernetes secrets allows us to encode in a highly, in a very well managed way, and sort of using a high level of encryption, a set of secrets that are distributed to all of those containers. Containers run inside of pods. Here's an example of a pod. A pod, if you like, wraps a container, and it wraps it with all of the environment variables it needs, such as those credentials and secrets, so that the container can have everything it needs, but at the same time, we can control where it's going, how it's running, and the information it's being given, again, as part of a well-managed, secure system. Kubernetes entities then, so we've talked a little bit about pods already. Deployments are sets of pods. So we can define how many instances we want of a pod, how we want those to be shaped across the cluster, and we can empower Kubernetes to distribute those loads for us. We can run multiple instances of a single pod, so if one crashes, we've still got a highly available service, and we can run a mixture, a heterogeneity of different pods across those things. Critically, Kubernetes takes care of all of that. So here we've got 3 hosts. You can see that notionally we're running Elasticsearch, Logstash, and Kibana again, but this time we're running it in a slightly asymmetric fashion. So on host 1 and 3 here, you can see that we're running Elasticsearch and Logstash. On host 2, we're running Elasticsearch with Kibana. And that's because what we want to ensure in our Elasticsearch instance is a highly redundant cluster, so that the data that Elasticsearch is holding on to never gets lost. We can cope with a node failure here, and the data which is sharded across all of those instances is going to be protected. Similarly, we've got high availability on Logstash, so that should we have a failure on either node 1 or node 3, it wouldn't matter. Host 1 or host 3 wouldn't matter, because the log information that's being routed to Logstash can go to either one of those. And finally, on host 2, we've got a single instance of Kibana. In this particular setup, Kibana wasn't critical, and so Kibana, which provides an interface that allows us to look at what's going on in the cluster and query it, that's not so critical for our service delivery. It's more of an administrative function, which is why we've got it running on just one node here. Not something the way we'd set up in production, but a good example, I think, of what Kubernetes will enable in terms of distributing these pods. So Kubernetes provides a few more entities, and there's often a lot of talk of services. Kubernetes services are again an abstraction, but it's one of the high-level things that Kubernetes delivers that makes our delivery of a quality service much easier. Those services are routed between multiple pods, and they hide the underlying implementation. So here we can see that we've got our same set of 3 nodes. We've got multiple instances of Elasticsearch, and in green we can see a service being abstracted by Kubernetes. Kubernetes will handle all the routing to that service, so it'll make sure that the traffic goes to the right pods, and it will continue to probe and check those pods such that if anything happens to one of them and they're no longer functioning or no longer performing well, Kubernetes can know about it and take it out of service automatically. It's sort of bringing together what we saw earlier with a combination of load balancer and secret manager, ingress controller, and also high availability sort of pod instance manager. All of that's wrapped up in Kubernetes, which means that what we get out of it is a quality service. I hope that's been helpful. If you'd like any more information, or if you'd like Lieutenant to help you with your digital strategy, please get in touch.